viewers, welcome to Physics Facilitator. So in today's class we will continue to learn laws of motion chapter, and already 3 parts of this lesson have been uploaded in our channel. Please do check that 3 videos also. Okay. So in today's class we are going to learn conservation of momentum and impulse. Okay. So firstly let us try to understand what is the meaning of conservation of momentum. Okay. So to understand this, let us take a small example. If you have two objects, okay, object 1 and 2, okay, so let us say the object 1 has mass m1, the object 2 has mass m2, and the object is traveling with a velocity u1 and object 2 is traveling with a velocity u2. Okay, so let us say these both objects are traveling in same direction. Okay, so here we have to assume that the first object and second object are traveling in same direction with a velocity of u1 and u2. So till this it is okay, but in case u1 is greater than u2, then what will happen? First object velocity u1, second object velocity u2 kanna ekku unnappudu em avutundi? Definitely there will be a collision between object 1 and object 2, right? So let us say this collision will be in a time period of t, and this collision time is very small, but let us assume the time as t. Okay, and let us say the velocities after the collision of object 1 and object 2 be v1 and v2. Okay, so u1 and u2 are before collision velocities of the objects, and v1 and v2 are after collision velocities of the objects. Okay, so what will be the momentum of the objects before and after collision? Let us find that. Okay, before collision be m1 and u1. Okay, so this is for object 1, and for object 2 it is m2 and u2, right? So how we got this? Simply in Newton's second law of motion we have studied that momentum is equal to mass into velocity. So here we are writing momentum before collision of objects 1 and 2. So what we are doing here? We are making a product of mass and velocity of particular object, that is object 1 and object 2, right? So what is the mass of object 1? It is m1, and the velocity of the object is u1. Okay, and what is the mass of the object 2? It is m2, and the velocity of the object 2 is u2. So m1 u1 and m2 u2 before collision. Okay, let us write momentum after collision. What it will be? m1 v1 and m2 v2, right? So what are the velocities after the collision? It is v1 and v2, right? So m1 v1 and m2 v2. Now let us write change in momentum. Okay, what will be the change in momentum? It will be m1 v1 minus m1 u1, right? We have to subtract final momentum minus initial momentum, and for second object it will be m2 v2 minus m2 u2, right? So for this, if you write rate of change in momentum delta p by delta t, then simply you have to divide this whole thing by t. Okay, we are writing rate of change of momentum, that is delta p by delta t. So we have to simply divide m1 v1 minus m1 u1 by t and m2 v2 minus m2 u2 by t. Okay, so here let us say the force exerted on marble 2 by marble 1 be F21, and the force exerted on marble 1 by marble 2 be F12. Okay, so in our last class, Newton's third law, we have learned that whenever an object exerts some force on the other object, the second object will also exert some force on the first object, right? So here what is happening? When the two objects get collided, the force will act on each other. Okay, So first object will act some force on second object. Second object will also apply some force on first object. So the force applied by the first object on the second object during collision be F21, and the force applied by the second object on the first object during the collision be F12. Okay, so according to Newton's third law of motion, the force exerted by first object on the second object is equal to the force exerted by the second object on the first one, right? So how we can write this? F12 equal to minus F21. Why we are keeping this negative sign? We are indicating that it was in opposite direction. The force was same. It was with same magnitude, but it was in opposite direction. Okay. So by this we can write rate of change in momentum as delta P1 by T equal to minus of delta P2 by T. Right. So let us substitute delta P1 and delta P2. What is change in momentum in first object? It is this. Right. So M1 V1 minus M1 U1 divided by T equal to minus of M2 V2 minus M2 U2 divided by T. So let us solve this equation. What you will get? T of M1 V1 minus M1 U1 equal to minus T of M2 V2 minus M2 U2. So T gets cancelled. So what you will be left over with? M1 V1 minus M1 U1 equal to minus M2 V2 and minus into minus plus M2 U2. So let us take this M2 V2 to other side and M1 U1 to this side. Okay. So what you will get? M1 U1 plus M2 U2 equal to M1 V1 plus M2 V2. Right. So by this you can understand that M1 U1 plus M2 U2 are the total momentum before collision, and M1 V1 plus M2 V2 is the total momentum after collision. So by this we can conclude that the total momentum is not changing before and after collision. That is, the total momentum is unchanged before and after collision. So by this we can say it as momentum is conserved. Okay. So law of conservation of momentum states that in the absence of net external force, okay, on the system, then the momentum of the system remains unchanged. Okay, so what is law of conservation of momentum? It is nothing but the absence of net external force on the system. The momentum of the system will remain unchanged. Okay, so by this you can understand what is conservation of momentum. Okay, next let us understand what is the meaning of word impulse. Why do an athlete, while doing a long jump or pole vaulting, he lands on a sand, not on a cement floor? And why do a fielder pulls his hand backwards while catching a fast moving cricket ball? So in these two situations, what is happening? What we are trying to do? So we are trying to reduce the velocity and we are increasing the stopping time. So the fielder, while catching the fast ball, what he is doing? He is pulling his hands downwards after catching the ball. So what is happening here? He is trying to reduce the velocity of the ball which he have catched. So if he don't pull his hand backwards, what will happen? With the high velocity, the ball is falling into his hands. So definitely he will get hurt, right? So this is same in case of pole vault or high jumps. What the athlete is doing? They are landing on a sand rather than landing on a cement floor. So what is happening here? If they land on the cement floor, they will definitely get hurt, right? So rather than landing on cement floor, they are landing on the sand. So after landing on the sand, what is happening? They will move to certain distance after landing on the sand. By this, they will get less hurt compared to landing on the cement floor. So what is happening here? The velocity is decreasing gradually. So let us say the velocity of the ball is 10 meter per second. So what is happening here? The fielder is trying to reduce the 10 meter per second of velocity to 0 gradually, right? So if he catches the ball with this 10 meter per second velocity, definitely it will hurt his hands. So what he is doing? He is trying to reduce the velocity gradually. Like say here it is 10, in this place it is 5, in this place it is 2, and in this place it is 0. So what is happening here? He is reducing the velocity. Same in the situation of landing on a sand. Okay. So what is happening here? The rate of change of momentum will be less. So the force of impact of the ball on his hands will be less. Right. By reducing the velocity, we are reducing the momentum. So by the rate of change of momentum is reducing, the force of impact will also be reduced. Okay. So by Newton's second law, F net is equal to change in momentum by time, right? So in order to minimize F net, that is force of impact, we have to increase the stopping time. So F net into delta T equal to delta P. So in order to reduce the force of impact, we have to increase the stopping time. Okay. So by this equation, F net into delta T equal to delta P, we can say that the product of net force and interaction time, delta T is interaction time, right? So the product of net force and interaction time is called as impulse of net force. Okay. And impulse is nothing but it is equivalent to the change in momentum that an object experiences during the interaction or collision. Okay. So the forces exerted for that time period are called as impulsive forces. Okay. So if you have egg and you are dropping the egg on the floor, what will happen? When you are dropping the egg on the floor, definitely it will break. What will be the reason behind it? Simply when you are dropping the egg on the floor, a large force is acting on the egg for a short time interval. Okay. And also the velocity of the egg is becoming to 0 suddenly. Okay. It is not decreasing gradually. It is becoming 0 suddenly. So the egg will definitely break. So let us say the momentum in first case is delta P equal to F net 1 into delta T1. So this is in case where the egg is falling on the cement floor. Okay. And again, if we take another egg and we try to drop that egg on the pillow. So this is the pillow or cushion, right? So when we are dropping egg on the pillow or a cushion, then what will happen? The egg will not break, right? So what is happening here? When the egg is dropped on the cushion, the egg is bouncing and reducing its velocity gradually, and the force acting on the egg is also reducing gradually. So what is happening here? The smaller force is acting on the egg which is dropped on the pillow for longer time. In first situation, what happened? Large force have acted on the egg for short interval. This is the reason the egg was broken. And when we are dropping an egg on the cushion or a pillow, what is happening? It is bouncing and reducing its velocity. So the velocity is reducing gradually to 0, and the force acting on the egg will be small in a large time period. Okay. So let us write it as the momentum in second case is delta P equal to F net 2 into delta T2. Okay. So if we say the momentum is same in both cases, then the magnitude of net force, that is F net, this F net will determine whether the egg will break or not. Okay, in both situations. So ఇందాకే నేను చెప్పాను కదా, why does a fielder catch a fast moving ball by pulling his hands backwards? Simply he is trying to reduce the velocity, reduce the force acting on his hands, right? So if he don't pull his hands backwards, what will happen to his hands? Definitely he will get hurt, right? So when he pulls back his hands, he experiences smaller force for a longer time period. Okay, so when the ball will stop, the ball will stop when he stop moving his hands backwards. So by this we can say that the change in momentum depends on the magnitude of force and also the force exerted on the object during that time duration. Okay, so by this we have completed laws of motion chapter. So overall with this video we have 4 parts of videos on this laws of motion chapter. In first video I have explained you Newton's first law of motion. In second part of video I have explained you Newton's second law of motion. In third part of video I have explained you Newton's third law of motion, and last part, that is fourth part of video, I have explained you conservation of momentum and impulse. Okay, so please do check all the 4 parts of this lesson so that you will have a clear understanding of the topics one by one. Okay, so please do like, share and subscribe to my channel, and please support my channel. So let us meet again in a new session with a new chapter.